Welcome all the dignitaries on this platform of FDP the topic for which is Enviro sustainability, and this is a pride honor for us that we have been registered under the banner of TechCube. So I welcome all the experts. I mean, today the expert will be Dr. Bhagyashri. Now, for continuing the lecture, I'll ask Dr. Devyanshi Jagwani to continue the program. दिख रहा
A warm welcome to all the participants. The speaker for today is Dr. Bhagyashri Korde. Can you hear me? Dr. Bhagyashri Korde. She is a young scientist at National Environmental Engineering Research Institute, which is headquartered at Nagpur. She is a PhD in chemistry, an environmental expert in water audits. She is a principal investigator in various types of CSIR projects. Presently, she's working as a DST young scientist, and along with numerous publications in national and international journals and conferences, she also guides postgraduate students. So I request Dr. Bhagyashri Korde ma'am to please start with the session today.
Thank you, ma'am. Ma'am, I want to share now my PPT. Just a minute.
Yeah, ma'am. Please.
Just a minute, I'm not getting the link. Sorry for that. Just a minute. I'll check it out. Browse.
Ma'am, you will see an arrow box जिसमें share screen करके option आएगा.
Yeah, but I'm not getting the desktop of my.
नहीं आप share screen करिए, then you get a window. तो उस पे window click करके share करिए. विंडो में एंटायर स्क्रीन करके आपको ऑप्शन आएगा. जब आप शेयर स्क्रीन का ऑप्शन क्लिक करते हैं ना तो उसमें एक विंडो ओपन होगी. दैट विंडो विल बी आस्किंग यू टू शेयर एंटायर स्क्रीन. आप उसमें क्लिक करके ओके करिए.
टीम्स के सारे ये दिख रहे हैं. एक मिनट थोड़ा एक सेकंड क्या बोल रहे हैं. हेलो एक
या मैम अब आपकी स्क्रीन दिख रही है.
Good afternoon all. I'm Dr. Bhagyashri Korde.
मैम आपका पीपीटी ऑन नहीं होगी. ऑन नहीं हुआ, आपने डबल क्लिक करिए।
दिख रहा है मैम ये?
मैम स्क्रीन दिख रहा है, पीपीटी ऑन नहीं हुआ।
पीपीटी ऑन नहीं हो?
नहीं मैम।
ये मैम हेलो
जी मैम।
हो गया?
मैम आपका स्क्रीन दिख रहा है, पीपीटी नहीं हुआ अभी ऑन। ओपन आपके डेस्कटॉप पे दिख रहा है मैम?
हाँ मेरे डेस्कटॉप पे दिख रहा है, तो इस वजह से मैं कंफ्यूज। मैं फिर से एक बार ट्राई करती हूँ, एक मिनट।
मैम उनको बोलो कि पहले
ठीक है।
आप दिख रहा है मैम? दिख रहा है।
Good
Yeah,
afternoon
please
all, and sorry for the inconvenience. I'm Dr. Bhagyeshri Korde, DST scientist from NEERI, CSR, National Environmental Engineering, Nagpur. First of all, I wanted to thanks Principal IPS Academy and of course Dr. Devanshi Jogwani for giving me this opportunity to deliver an expert lecture in 1 week FDP on eco-enviro sustainability under TechWip 3. Now, my webinar topic is on water environment and its management. So, we all know that water is very important in our day-to-day life. With that, being civil engineer faculty, you might be having some research thoughts also. So, I'll be briefing on what kind of research, if suppose you wanted to perform with water environment and its management, and I'll be ending up with means in that suppose you wanted to do the sampling, if suppose you wanted to do the analysis of these water samples, how can you proceed with that? At the end, I'll tell you the management, exact management, how to perform through water audit. This scheme is very new and we are performing it on as a CSR activity of one of the company, and that activity we are performing from last 1 to 2 years, and we are getting very good response. We have performed it on school level where the ETP, STP and rainwater harvesting system now they have installed, and somehow industries are paying the company for these type of water audits, but being a CSR activity, we are not taking that much of money. But yes, you can perform this activity and take the projects of your students on this activity so that they can turn it to the business in future, because water problem will be the biggest problem, and now also it is the biggest problem in all over the India. So let us begin. The structure of the presentation will be, yes, I have told you in brief background of water scenario, water quality issues, and then how to manage this water with water quality issues. About water, yes, a single source has no substitute. सब जगह सिर्फ पानी ही एक है जो यूज होता है, right? Then a limited scarce resource. Yes, we are getting water from rain, which is the potable type of water. There are other resources also. There are other sources also, but from rain only we are getting the pure and drinkable type of or potable type of water. Then has social, economic and environmental values. Social and environment are recent. Previously it was having only economic value. And then water impacts all aspects of life on the planet. Poor water management and water shortages can lead to disease, malnutrition, reduced economic growth, social instability, conflict, and environmental disaster. And this water management also we will be going through this presentation. Then, first of all, let us find out what is water pollution. presence of undesirable substance in the quantities which are harmful to man, vegetation or property. Pollution, all of us know that to make whole or unclean, dirty is nothing but pollution. Now, what are the indicators of water pollution? We know that by seeing also we can say that this water is pure or not. These characteristics like seeing, smell, and then with the virtual characterization, we can say the physical characteristics. We can tell that whether the water is polluted or pure. Then the contamination by fecal or organic matter. These we cannot say that whether the water is pure or not. For this, we have to do some analysis for organic matter, fecal coliform. Then toxic pollutants, organics, and heavy metal. For these also, we need analysis work with sophisticated instruments and all. Now, let us have a look on one video which will give you brief about water pollution. So this type of pollution, if suppose we are looking into, so then how to deal with this pollution? Either you can have some research projects related to this, or by simply environmental monitoring also, you can perform some activities to purify the water or to analyze the water to the level that you can get the impact on the social or economic aspect. Now, see over here, ये जो आप area देख रहे हो, that area is having causes of surface water pollution. Now there are two types of water. All of us know that one is surface water and other is groundwater. In surface water, if suppose water is getting polluted from rivers, pond, if suppose the water is getting polluted, from where the pollution is coming. So we need to see where are the point sources and non-point sources. Here you can see over here all the things, whatever happening around the river is not point sources, but the discharges from wastewater treatment plant and the factory outlet is the most point sources for pollution in river. With that, causes of pollution, groundwater. See, groundwater. Hello, hello. Am I
Yes,
audible?
ma'am.
Hello.
Yes, ma'am.
एक्चुअली मुझे बहुत आवाज आ रही है मैडम, इस वजह से मुझे लगा
I request all the
डिस्टर्बेंस।
participants to please mute their mobiles or connections. Please, participants are mute continue.
Okay, I'll carry on. So with the ground
Ma'am, please आप unmute करिए. Bhagyashree ma'am, please unmute करिए. I cannot hear you. Ma'am, please unmute your system. Ma'am, unmute करिए please.
hello, is it okay now, ma'am? Hello, hello, hello. हाँ मैम, अनम्यूट कर दिया मैम। हेलो, हाँ हाँ आ रही है शायद। मैम चेक कीजिए प्लीज, आप ठीक है ना? Ma'am, PPT is visible?
Yeah, visible.
Yes, ma'am.
Okay. So all these are the groundwater pollution sources, causes, I can say. If suppose pesticide industry is there, pesticide is getting leaked out to the groundwater. And then what is exactly water environment is? It contains sources of water, from where exactly the water is coming, their requirement and utilization. For which purpose you are using that water is also important to analyze that water or to monitor the water quality. Then detailed water balance has to be there, means whatever will be the consumption or utilization, that should be the requirement over there. And so the source should be that much enough to give that kind of water or that much of water. Then the breakup of water requirement as per the different activities should have been there. With that, approval of competent authority for utilization of ground and surface water should be there, like corporations we are getting. And wastewater parameters are given over here. Then groundwater parameters are also given here. What kind of monitoring and water quality parameters we should go through for surface water and groundwater is differentiated over here. So you can have a look over here. I am not going for much detail in this. These are the basic things. Now in detail we are having for the water quality. What is water quality? Those physical, chemical or biological characteristic of water by which the user evaluates the acceptability of water, degree to which a set of inherent characteristics fulfill requirements. Means for drinking, what we need is the purest form of water, wholesome, which is potable one. For irrigation, yes, we need TDS in it. and some toxicants should also be there. We need it. It should be removed. Okay. For outdoor bathing, pathogens should not be there. All the other things, rest of the things in needs is from industry specific water quality needs. If suppose you are going for specific industry, their demands for water, purity of water differs. Okay. Then water contaminants. Water contaminants, yes, different particles if suppose are there, means colloidal, suspended, so many particles are there. Bacteria, mosquito, all. Then gases, ions, organics, pH, then so many organic matters also from animal waste also the organic matter comes into the water that should be properly clean. Ions in the form of hardness, all of you knows, and some dissolved gases are also there. Water quality standards, yes, there are some standards by regulatory bodies which has to be through मैम सब कुछ डिस्टेंस कुछ है थोड़े डिस्टरबेंसेस आपको वॉइस आ रही है
Yes, ma'am, आपकी voice आ रही है. I please request all the
मेरी आती
participants
है
कि
ना
आप
क्योंकि
mute
मुझे
पे
बीच
जाइए.
बीच हाँ, ठीक है
Yes,
ना
ma'am,
मैम ठीक है
disturbance actually cannot locate कि कहाँ से हो रहा है, but we've asked the participants to please mute their.
नो इश्यूज मुझे ऐसा लग रहा है फिर बीच बीच में मेरी आवाज कट रही है ओके नो
Ma'am,
इश्यूज
थोड़ा सा network issue है, but we can hear you.
ओके वाटर क्वालिटी स्टैंडर्ड्स जो है वो वाटर क्वालिटी स्टैंडर्ड्स हर जगह अलग अलग तरह से डिस्क्राइब किए जाते हैं. हमारे सीपीसीपी के कुछ अलग गाइडलाइंस है. विद दैट डब्ल्यूएचओ के गिवन कुछ गाइडलाइंस है. बट इस कंसर्न में मैं हमेशा ये कहूंगी दैट इज द प्योर दैट इज द कंसर्न ऑफ माइन ओनली. हेलो हेलो
I request participants to please don't disturb in between. Please mute करिए participants.
So if water quality standards is concerned, we can say that हम लोगों के आसपास भी हम ये सब देखते हैं और हमारे यहाँ पे भी हम ऑब्जर्व करते हैं कि कुछ लोग जो थोड़ा विलेज एरिया से है वो थोड़ा हार्ड वाटर भी पचा लेते हैं. राइट, दे आर हैविंग दैट टेंडेंसी. वो पीते भी है, बचपन से पी रहे हैं. सो दे आर नॉट फेमिलियर विद द कॉर्पोरेशन वाटर कमिंग टू आवर हाउस. सो इस वजह से मैं इन स्टैंडर्ड्स के लिए ये बोलूंगी कि हर स्टैंडर्ड के लिए उस तरह से नहीं देख सकते. दैट as per as small parameters, essentially basic parameters are concerned like color, odor, taste, turbidity, pH, total hardness. But yes, iron is critical one, chlorine is critical one, residual free chlorine is also, if suppose there, it is also critical one. Now desirable characteristics are there in water and which makes the water quality standards has to be maintained properly. If suppose these parameters are there in water, yes, it will harm your health so and your industrial work also and so many things. Okay, you can see over here TDS, nitrate, phenol, heavy metals, cyanides, anionic detergents, pH, polyaromatic hydrocarbons, and mineral oil. All these are very toxic and very harmful to our
एक्चुअली पता
body.
है क्या, मेरे हाथ में होती ना बात तो मैं कर देता, नहीं मेरे पास होता बच्चा. अरे आपको पता है मेरे को तो यहाँ टिकने नहीं देते हैं, मैं ज्यादा
Sir, please आपको mute करिए. Please mute your system.
Please mute कर लीजिए. It is a wonderful lecture and we really wish to have a good knowledge on this topic. Please आप लोग अपना mute कर लीजिए. And if you are not interested, please बंद कर दीजिए थोड़ी देर के लिए. Please.
डायरेक्ट बात करो क्योंकि
मैम एक पॉसिबिलिटी ये भी है कि आप अपने एंड से सबको म्यूट कर सकते हैं. द ऑर्गेनाइजिंग टीम मेंबर आप अपने एंड से सबको म्यूट.
चलो कोई.
Yes, ma'am. Yes, ma'am. आपने सबको mute कर दिया.
Ma'am, shall I start?
Yes, ma'am. Please continue.
Water quality standards. So water quality standards are having certain criteria, objectives, and standard. Okay, with that, what guideline you are following need to be supported, maintained, and designated with proper water use. As the criteria is given for various criteria are for various usage of water. For what that water is to be used is to be known, and then only we can get this type of guidelines. Then the objective, what type of work you are doing. If you wanted to drink that water, yes, you need to have different criteria. But if suppose you wanted to use it for irrigation, it is having different criteria. Then water quality standards, yes, water quality standards objective, that is recognized, as I have told you, that for different purposes, if suppose we have selected this type of water, then enforceable environmental control laws and regulations of environment or government should be followed, by which water quality standards can be maintained, and you can use that water and you can discharge also in that way. Standard is legally enforced. Yes, nowadays, from environmental impact assessment studies, uh, from where the data is getting generated and so many things happening. So MOEF, Ministry of Forest and Environment and Forest, is taking care that the legally enforceable procedures should be there, and then only you can use that water for drinking and for industrial and any type of use. So properly implemented and ensures safety of drinking water supplies only will give the standards of water quality. Then these are the BIS limit, Bureau of Indian Standards. And significance, physical parameters are mentioned over here. That is temperature. Yes, ambient temperature is good. These are the desirable limits and these are the permissible limit. You might be knowing this. Desirable means it should be there. Permissible means if suppose that water is around you and not for the drinking purpose or not for that specific purpose, the permissible limit can be this much. So you can see temperature, color, odor, taste, turbidity, pH, conductivity, TDS. So many parameters are there. Among them, color, odor, taste, turbidity, all these parameters are aesthetic quality, have aesthetic qualities. So with this, no need of so much of instrumentation and analytical procedures, but we can have a look and have a smell. With that we can see that the water is good or not, and it will aesthetic quality is nothing but the smell, taste, all these things, all by all these senses we can monitor color, odor, taste, ability. But the pH, conductivity, TDS, all these things we need some sophisticated instruments or at least litmus paper for pH. Conductivity units are mentioned over here. Conductivity is related to the TDS, total dissolved solids, and total dissolved solids we are measuring by ppm, that is parts per million. Here TDS, if suppose is more, conductivity if suppose is more, what we are getting is palatability decreases. We are getting some irritation, stomach, all these things happens sometimes. कभी ना कभी हमारे साथ ये हुआ है जब भी हमने कहीं का बाहर का पानी पी लिया है या हार्ड वाटर पी लिया है. These are the BIS limitations for other chemical parameters. Total hardness should be 300, desirable, and these are the significance effect. Again here, gastrointestinal irritation, you can see over here. Adverse effect on domestic use, hardness. If suppose hard water is there, you cannot get the foaming of your leather. डिटर्जेंट्स के साथ ये होता है, फिर washing machines choke हो जाती है. Okay, and then calcium, magnesium, these are the form of hardness only. These are also having the permissible limit. Chloride, sulfates, fluoride, alkalinities, nitrate, phosphates, all these are having various adverse effect. We will see this afterwards also. And then copper, chromium, cadmium, zinc, lead, mercury, iron, manganese, all these are heavy metals. It should not be there in water. If suppose it is there, the desirable limits are here. Otherwise, you will get very, very, very bad impact in your body or any type of work you're performing with it. Then BOD and COD, these are not having any desirable or permissible limit, as these BOD and CODs are the demand parameter. Okay, biological oxygen demand and chemical oxygen demand. indicate organic pollutions. If suppose organic pollution is there, it cannot be give limitations that how much should be there. It should not be there. And yes, oxygen demand has to be there to the water, because with unless and until oxygen is not there, we the living animals or living things will not survive. So with the phenols, oil and grease, pesticides, all these are the discharges we have seen in groundwater just now in last slide. And now we are seeing the permissible or desirable limits for it. But all these are the toxic parameters. All these are the toxic contaminants. Then the biological parameters also, total coliform, fecal coliform, these should have been strictly zero. Otherwise, we can have typhoid, cholera, jaundice, dysentery, and all these type of dengue, malaria, सब हो जाता है. Okay. Then biological parameters में और एक zooplankton, phytoplankton, these also should be monitored. And with this also the pollution in the water will be big. हम देखते हैं जो भी green matter onto the surface of water जो दिखता है हमको, that should be avoided. Is zooplankton, phytoplankton. Then radioactive elements, of course alpha emitters, beta emitters should not be there. But still, if suppose in some areas these emitters are present, the permissible limits are given over here, and that much is permissible, but not for the drinking. Again, these are the parameters, standard parameters from CPCB guidelines. You can see over here, they have classified it in class A, class B, class C, and class D on the basis of usage of water. And they have given the proper, that's why I have said in my earlier in my earlier slide that we cannot make a standard in such a way that this is the standard and now you have to stick with with these standards, because all the type of other work also needs the standard, and those standards are being classified over here. These are some more: temperature, odor, color, general standards for discharge of effluents. Now here, up till now, what we were seeing is the standard parameters for the usage. Now, if suppose you are discharging your effluent, that is the treated water, into the river or into the nala, then that should have again some permissible limits, some standards, and it is given over here. These are also categorized in N1, N2, N3, N4 according to the industrial effluent discharges, and they have given the permissible limits. Now, how to do water analysis? This is the very important part. We have to first select the location. We have to see where is the location or from where the water samples to be taken. Because see, if suppose the river is so long, you cannot take the sample of whole river at each point. You cannot monitor like this, but you have to select some locations, peak location, or I can say point sources from where the sampling can be done. Sampling, then preservation, and then with the proper labeling only you can start your analysis. Then first of all, select the parameters for which or your need with for which you are analyzing this water sample. Then after analysis, for analysis you need different instrumentation, different analytical procedures. With these procedures you will report some values with accuracy and precision. All these parameters you might have studied in your 11th. Accuracy, what is accuracy, what is precision? These are the just methodologies, how you are performing your experiments, how good your apparatus, how efficient your instruments are. So these are the water analysis steps. Then water sample collection. Yes, sampling is very important in our whole water environment or water monitoring study. Where to do sampling exactly? There are 3 types of sampling procedures, that is grab sample and catch sample. So grab sample, catch samples are the samples. If suppose you are taking sample at one point at one time, that sample we are calling it as grab sample or catch sample. But somehow for some studies it is not permissible that you will take one sample and check out the report. But for that you need to take so many samples. So some seasonal studies are there. सीजन्स में आप स्टडी करते हो, टाइमली करते हो, सुबह दोपहर शाम आप सैंपल्स लेते हो. Those type of sample collections is called composite sample. And if suppose integrated sample is there, means if suppose you are taking the sample from different locations with different might contamination sources, then at that time integrated sampling is the most useful one. Now, then how to design the program of water sampling? You first have to clear your objectives, then what parameters you need to analyze, levels of accuracy, what should be maintained, and use of data, because all the parameters does not need so much of accuracy, but yes, some parameter like the heavy metals, toxic heavy metals needs accuracy. Then sampling location, you have to see from where to take the samples exactly, otherwise you will be searching for the sample to some other area and sample would have been at the point source, right? So sampling frequency, that when to take sample. If suppose the discharges are from in the night and you are taking sample in the morning or in the evening, so the impact of that discharge onto that river, क्योंकि देखिए पानी तो बहता रहेगा, so with the flow it will go. And if suppose you are taking samples so with no time limitations, its sampling frequency will again matter. Then sample collection, on spot analysis, sample preservation. Sample preservation plays important role, because if suppose you wanted to take the metal analysis, you can want to carry out metal analysis, आपको क्या करना पड़ेगा, सैंपल को एसिड कंडीशन में प्रिजर्व करके रखना पड़ेगा. अब एसिडिक कंडीशन अगर मेंटेन नहीं होती है तो यस, योर मेटल विल गेट डिटोरिएट. Then analytical methods and instrumental techniques you have to perform, like ICP, AS, कुछ titrations होते हैं. With that also you can get the results. Then again you have to handle that data properly and report it properly, because so many times what we have seen that analysis हो जाता है, sampling हो जाता है, बहुत सारी चीजें अच्छे से हो जाती है, लेकिन जब डेटा हैंडल करते हैं, उसमें ग्राफ्स बनाने होते हैं, रिपोर्ट करने के लिए उसके टेबल्स बनाने होते हैं, एट दैट टाइम कुछ मिस्टेक्स हो जाती है और रिपोर्टिंग में वो चली जाती है, तो बहुत प्रॉब्लम हो जाता है. And we suffer a lot. Now let us move towards the instrumentation. Now for detection of color, we need one specific instrument that is called colorimetry. Okay, in this colorimetry we are getting the color. Yes, by seeing also we can find this, we can see that whether the water is having color or not, but somehow somewhere what type of color or why this water is giving color, if we wanted to monitor, we need a colorimetry where metallic ions, humus, peats, plankton, beads, and industrial waste gives color mostly to the water. And it is having one unit, special unit. It is called as Hazen unit. Desirable limit is 1 Hazen and permissible is 5 Hazen. You can see true color due to dissolved material, apparent color due to suspended matter, and the visual comparison and spectroscopic methods are very good for color analysis. After that, we are monitoring turbidity. With the For this turbidity, we need one instrument which is called as nephalometer, and its unit is NTU. That is nephelometric unit. And the reference what we are taking for this instrument is formazine. Now what is the logic behind it, or I can say the science behind it? By refracting the light onto the turbidimetric solution, we can get how much turbidity is and how much is the suspended solids and colloidal solids are there. So after that, pH is also getting monitored. We all know that drinking water should have pH in between 6.5 to 8.5, but all the other purposes also needs water, and that type of water can also have varying type of pH limit. So the pH monitoring is the most important one, which will tell you whether the water is acidic or basic in general terms. And water supply, wastewater treatment plant, all these things need water pH of monitoring pH of water. Then measurements are by electrometric method. Then with EMF produced in glass electrode with vary, and you can do it with litmus paper also. Then conductivity. Conductivity is measures of electrical conductivity of water. Okay. Then higher the value means water is a better electrical conductor. Means it contains more salts, that is dissolved salts, and indirect measures of salinity. If suppose we wanted to calculate the salinity in irrigation purpose, for irrigation, this conductivity plays important role. If suppose more salted water is there, the crop will not survive. So this conductivity parameter is very important for them. Then TDS, total dissolved solids. Yes, solids again, dissolved means salts. Portion of solids that passes through a filter of 2 micron or smaller pore size is total dissolved solid. Then yield values for TDS closer to obtained through summation. At this temperature, all mechanically occluded water is lost. Some some samples may require prolonged drying and desiccation. So with the evaporation and so many processes, we can do this TDS. And evaporation method is the only method for TDS. Then palatability decreases. Again, gastrointestinal irritation. I have told you all these things. Then conductivity calculations, at the temperature, specific temperature we have to do at 180 degrees Celsius. Again, then alkalinity. Alkalinity is again the form of dissolved solids when salts, carbonates, bicarbonates, hydrocarbons, borates, phosphates, silicates, other bases. Due to all titrable bases, the acid neutralizing capacity what water is having, we need to monitor by through alkalinity parameter. It should have the limit of 200 to 600 milligrams per liter, and all these are the specific parameters. If suppose alkalinity is equal to hardness, means calcium and magnesium salts are present, and so many things are there. So with that, hardness is again presence of calcium and magnesium salts. Yes, you all know, must be know, because in engineering first year you are having hardness in our syllabus. Hardness of water, capacity of water for reducing and destroying the lather of soap, defined as the sum of calcium and magnesium expressed as calcium carbonate milligrams per liter. It is having limit as 300 to 600 milligrams per liter according to BIS standards. Then iron. If suppose iron is there, the iron bacteria may get into the water, and that's why iron should not be there. Its acceptable limit is 0.3 milligrams per liter. And some health effects also, we can get some liver diseases, hemosiderosis, then hemochromatosis, and chronic fatigue, arthritis, heart disease. So many problems are there. That's why iron should not be there in the water. It should have very low, if suppose it is. Then nitrate. With the nitrate also, fertilizers, manure, animal dung, nitrous materials, sewage, all these are the sources of nitrate, and maximum permissible limit is 45 milligrams per liter. But if suppose you are having this nitrate in water and you are drinking that water, you will get the cyanosis of the nail beds, oxidized hemoglobin, unable to carry oxygen effectively, and we will find blue baby syndrome also. With the fluoride, you might be knowing in Maharashtra, in nearby Maharashtra areas, Chhattisgarh and all, this fluoride problem is very high. And what we are getting with this is dental fluorosis, skeletal fluorosis, non-skeletal fluorosis. Acceptable limit is 1 milligrams per liter. And remedy is to take vitamin C, D, mixing fluoride with free water, and yes, defluoridation. NIRI is doing good work on this defluoridation technique. Then arsenic again occurs in groundwater for arsenious belt. In Gangetic plain, we have found this arsenic contamination in water. Industrial waste, insecticides, because of this arsenic is getting contaminated. Acceptable limit is very low, that is 0.05 milligrams per liter. You can see melanosis of trunk, keratosis of sole. So many problems are there, like fluoride. Then DO is the demand or dissolved oxygen, and it is of demand. It should be there in water. If suppose it is there, the critical for which is critical for the survival of aquatic plants and animals. 5 to 6 ppm sufficient for most species, but if suppose less than 3 ppm, stressful to most aquatic species. So most of the aquarium and other things are taking care of all these things. So plants and animals respiration, decomposition of waste. Yes, fresh water hold more oxygen than salt water. Cold water holds more oxygen than warm water. Greater the atmospheric pressure, the more the DO. Modified wrinkle method and DO meter is the measurement techniques. BOD, again, definition, a bioassay test involving measurement of oxygen consumed by microorganism while stabilizing biologically decomposed organic matter under aerobic conditions. Biological oxygen demand, it is. And limits are given over here. Need, the degree of pollution in water sources, self-purification, capacity of sources, designing of treatment facilities, then efficiency of wastewater treatment methods, and measurements are by azide modification of wrinkle method, DO meter, and a 0-day DO and 5-day DO at 20 degrees Celsius. Then COD, oxygen equivalent of the total organic matter. COD is chemical oxygen demand of water. Oxygen equivalent of the total organic matter in a water sample that is susceptible to oxidation by a strong chemical oxidant. COD should is always greater than BOD for any given sample and is typically greater than 20 milligrams per liter in unpolluted waters. Need to assess the water pollution to determine pollution load of wastewater and designing of treatment facilities. So with this COD monitoring only, we will determine what treatment facility it should be given. Then potassium dichromate consumption, only one method is there. By titrametric, we are measuring this. Interferences, yes, so many interferences also there in titrametric procedure. Nitrogen, again, nitrate and nitrite, these are the two forms. Total geldal nitrogen we are calculating, and through this ammonia nitrogen and organically bonded nitrogen we can calculate. Then freshly polluted water, organic nitrogen and ammonia under aerobic conditions, biochemically oxidized first into nitrite, then into nitrate. So nitrogens are having various forms. Measurement, of course, Geldal digestion method is the best one. Then titrametric method for ammonia is also there. Persulfate digestion method oxidizes all nitrogenous compounds into nitrate, ammonia and nitrate selective electrodes. Ultraviolet method for a nitrate in fresh water. Then phenol, oil and grease, all these are having various impacts on the on your work with the water, and chlorination of such water may produce chlorophenols, which is also highly impactful. Then colorimetric method is used to detect phenols. Then oil and grease contains hexane. Partition gravimetric method is there to detect oil and grease in water. Some toxic metals, yes. If suppose these toxic metals are there, means again it will be problem. So colorimetric method are tedious and time consuming. And now some sophisticated analysis method are there, that is atomic absorption spectroscopy and inductively coupled plasma spectroscopy. The field instruments, yes, that these instruments we can take to the field and directly take the measurements for color, turbidity, pH, conductivity, alkalinity, total hardness. Nowadays, we are getting a kit from the providers in which all these field instruments are there. Analytical instruments, lab based, all these lab based instruments like ion chromatograph, ion selective electrode, turbidimeter, ion chromatograph, again ion selective electrode, atomic absorption spectrophotometer, inductively coupled plasma, all these are lab based instruments. You have to monitor your samples in lab with these instruments. Analytical instruments for specific analysis. If suppose you wanted to do some specific analysis, like you wanted to calculate methane. For that, you need gas chromatography. For pesticides, also you need gas chromatography with ECD and NPD detector. For dioxin, furans, you need again gas chromatography with mass spectrometer, that is GCMS. VOC is pH, gas chromatography with FID detector you need, that is the detector FID, and various detectors are getting changed with respect to the toxicants. Like in PCBs, chlorinated hydrocarbons, you need ECD detector with gas chromatograph. Then bacterial analysis, yes, for coliform bacteria, you need to see warm-blooded animals if suppose they are in the water. FCs indicate the presence of disease-carrying organisms which live in same environment as the fecal coliform bacteria. Methods are most probable number and um, perceptive, confirmatory, and completed. Membrane filtration, H2S, vial. These are the methods by which we can detect. But fecal coliform bacteria should not be there in water in any form. If suppose it is there, it will not be of data. These parameters. If suppose these parameters are good, okay, homogeneous samples, calibrated equipments are there, instruments are there, appropriate.
I request all the participants to please mute. Please आप mute करिए participants.
Thank you. Adequately described procedures, if suppose are followed, then trained and competent persons are doing these all analysis is the good for data, getting good data. And then the data generation process also is important, how you are generating the data and what type of quality of water now you are getting and what was expected should be matched, or otherwise if suppose it is not matching, you should get the sources where the contaminations are getting into the water. So all these were the water analysis procedures. Now I'll turn towards the water management, which we are performing by doing water audits in various organizations. For that, I'm having one video. Just go through this video, which is nothing but for water conservation, where we're wasting water in day-to-day life, and how we can conserve it by doing some simple steps. Just watch this video for 5 minutes. Now, hello, am I audible?
Yes, ma'am.
Huh.
Yes, ma'am, you're audible.
Okay. वाटर सिनेरियो इन इंडिया वी आप सबको पता है कि हम डे 0 की कगार पे हैं और नॉर्मली और हम ये 21 शहरों को तो अभी देख चुके हैं जो ऑलरेडी वाटर नहीं के बराबर है यहाँ पे, राइट? सो इंडिया विल सून बी अ वाटर स्ट्रेस्ड कंट्री एंड वी ऑल नीड टू वर्क टुवर्ड्स आवर वाटर सिक्योरिटी. सो फॉर दैट, यू नो द क्राइसिस ऑल ओवर द इंडिया. बहुत जगह से लोग अपने घर छोड़ के आ रहे हैं इन द सिटीज बिकॉज वाटर इज नॉट देयर, which is a very severe issue. ये दिन भी देख सकते हैं हम कि पेट्रोल डीजल और उसके साथ पानी की भी एक टंकी लगी हुई है जिसमें से पैसों उसके साथ पैसे दे के हमको पानी मिल रहा है. So because of this scenario, we have gone through one procedures, or we are doing these procedures in different organizations. I wanted to share it with you, and yes, you will be getting benefited with this. We are calling it as water audit. So we are going to some organizations like specifically we have done it for schools. हमने schools के लिए ये बहुत ज़्यादा किया है नागपुर में, in नागपुर city specifically. तो वहाँ हमको response बहुत अच्छा मिला है schools से या colleges से. टीम वर्क बहुत अच्छा मिल जाता है. बच्चे बहुत अच्छे से उसको परफॉर्म करते हैं, बहुत अच्छे से उसको प्रेजेंट करते हैं, डेटा जो है वो मैनेजमेंट तक पहुंचाते हैं, गवर्नमेंट तक पहुंचाते हैं. विद दैट they are about to set up now the rainwater harvesting, then wastewater treatment plants in their schools, colleges. So now see what type of work we are doing for getting this type of data through which we have done this water audit. Now see over here, water audit is a qualitative and quantitative analysis of water consumption to identify means of reducing, reusing and recycling of water. Now what we are doing here, we are now up till now we have done some school water audit where in first step we have seen that how much water does your school use. We are asking this question, and with this question, with
So,
this question,
participants, please mute Kariya.
what we are telling them is to monitor their bills, meter readings, water survey, water use survey, trending water use, graphing, interviews, all these things. You have to ask somebody to how much water you are giving to plants. If suppose a gardener is there, if suppose so many things are there which are going around and around in your school, for those things you have to manage. Then where does your school use water? In taps, surveys, toilets, interviews, gardens, ovals, pools. Then how can your school save water? By promoting to community, interpret data, become a water-wise school, ongoing actions, water curriculum activities, and reports on finding. Actually, with all these data, schools are getting benefited with their accreditation system also. So if suppose some good organization, and yes, some industries are also wanted to get this type of audit to minimize the water consumption and reusing and recycling of water. So I request all of you to pay attention to this and just perform this activity with your students to make them achieve for their future as a business or as a yes, some kind of social activity also. So how much water does your school, college, apartment or organization use? The first step in being able to reduce your water use is to understand how much water is being used in day-to-day activities. Prepare your students or peoples for the audit by researching water topics such as the location of your water resources and any local current water conservation measures in place. Looking at your water bill, you just monitor your water bill and your usage per day in your school, in your organization, or you can do this activity at your home also. Okay, you can plot a graph with meter reading and usage of water. How? Let us see. Where does your college use water? Locate the areas first. student could create their own maps of the college. Means where are the toilets, how many are there, staff rooms, how many staff rooms are there, how many tabs are attached over there, change rooms, if suppose some water is provided over there, vegetable garden, then other gardens, playgrounds, so many places we need water. Then how can your college or your organization save water? Investigations and develop solutions from the results. And if suppose you have collected the data that how much water we are using, then you can collate the findings and investigate and develop some solutions from that. Various solutions like identify area of water leakage and take corrective actions, educate students, staff members on water conservation, identify area for rainwater harvesting and implement it, implement water wastewater treatment in college premises for recycling of water, then action to conserve water. This is you very well known. Being a civil engineer faculty, rainwater harvesting system has to be adapted by all, every organization, at each and every home. There should be rainwater harvesting system. Investigate leaking taps. As you can see over here, dripping of water from the tap can waste total for a day 7.2 liters per minute. And if suppose this type of wastage is going on and you're having one or more taps like this in your school, in your college, in your organization, then how much water will be wasted? You can see over here. Water consumption pattern, so many are there in our house. And one more thing I wanted to tell you, that this water audit concept came into my mind when our own childrens are getting were getting their this problem in school in summer days. Actually schools were asking them to carry two water bottles. तो दो पानी की बॉटल उनके लिए लेके जाना was very difficult. पहले ही बैग इतना भारी. So we have thought, why should not we audit the water in school? If suppose we are monitoring the water, and if suppose with these systems school is getting water conserved and reuse also, so that will be good. And yes, one of the school got benefited with this. If suppose time permits, I can show you the success story for one school. And they have implemented their rainwater harvesting system, then treatment plant also. With that they have put up this story to the needy organization also, that what kind of activity they have performed and what type of results, and now how they are getting benefited from by 2019 to 2020, how much water they have conserved. All these data we are having with this water audit. Then was wastewater management also. For this two category of wastewater, black wastewater and gray wastewater. Recycling of wastewater, if suppose we can do with sewage treatment plant, is the best method of wastewater management technique at school, colleges, and each and every organizations. So write a report where you have to write how much water your college uses with meter readings, water bill analysis, and some MS Excel graphs. Where your college uses water, explain the ways that students and staff use water, describe the activities that use the most water, use a pie chart for that, photos taken during the audit, observations of the water used at college, how your school can save water, see that. And yes, before completing my presentation, I wanted to share mm, I wanted to share some Excel sheets and some documents with you. Through which you can calculate the exact water you can conserve per year by rainwater harvesting system. You can see over here. Hmm. Is this visible? Huh?
No, ma'am, not yet.
Rainwater harvesting calculator.
No, ma'am, I cannot see it.
Is it visible?
Yes, ma'am, now it is.
Yes. Now, in square meter, you find out the roof area of your college, of your organization, and you just put that value here. Roof area, if suppose any other area is also there, you can put the value here. Then total roof area, it will get added with this calculator. And yes, rainfall received yearly in your city, you just put the value. Then runoff coefficient, yes, first flush water system is there. With that flush water, the first water will go out of your rainwater harvesting system, and then whatever will be the remaining water, that total catchment per annum will be given here. You can see this value 1787 cubic meter. Now here we can see that total catchment per annum in liters will be 17,87,940. This much of water you can save per year if suppose you are having proper rainwater harvesting system. Okay, this is the one sheet with proper management, proper designing of your water audit. You can do this, and it is not very difficult. We can manage it very easily. With this, one more document I wanted to share. It's taking too much of time.
No problem.
Now in this document, actually, you can see, yes, now if suppose you have done your water audit study for 2019 and 2020 and so on. What type of unit consumed, what type of water consumed, all these data will be there on one paper to you. With this, you can have your yearly water audit on one paper, and the system will be set in first year only. Then afterwards, one person will be sufficient to see the things and take the data, and you can have so many things in one or two papers only. So you can have this report. I can share these two uh, documents to you to perform water audit in your college, in your society, in your organization, wherever you are there, you wanted to do it, so that you should not get water scarcity in future also. So you can get from this uh, document annual net water savings what you are having now after sewage treatment system, after rainwater harvesting, and previously also for putting this rainwater harvesting system, sewage treatment system, what KLD of sewage treatment plant you need to implement in your area, that also you only can calculate. No need of any other organization or क्योंकि सीवेज वाले आएंगे, ट्रीटमेंट प्लांट वाले, तो वो तो बड़ी कैपेसिटी बताएंगे, वो बोलेंगे कि भाई आपको इतना लगता है उतना लगता है. दिस यू कैन मॉनिटर बाय योरसेल्फ. बहुत इजी है, कोई बहुत बड़ा टास्क नहीं है ये. So these are the documents I can share with you. With this, I wanted to show you the success story, ma'am. I'm having time or not? Hello, Mitu ma'am. Devanshi
Yeah,
ma'am.
ma'am, please continue, please, ma'am. We would like to hear the success story.
Okay, okay. Thank you, ma'am. Thank you. Water audit final. This is the school, Bhavans Vidya Mandir, civil lines in Nagpur, where we have performed water audit activity. And this PPT is prepared by students and teachers of the school, and solely by the students. And all the work has been done by the students of 8th and 9th class. And they have done very good job. They have presented this water audit procedures in so many organizations on behalf of us and as a success story. And they have implemented a wastewater treatment plant and sewage treatment plant, and with that rainwater harvesting system also, by locating the area where should it be planted. This is their PPT. Why is water audit? What is its need? And all these things they have given. You can see over here very nicely. They have quoted it. Then uses of water at our homes, drinking, cooking, bathing, flushing, so many things they are mentioned. And they have mentioned over here that 115 liters per day per person we are using water in our homes. So this data they have
Ma'am,
got
we are
by their
unable
first experience.
ma'am, we are unable to see the slide.
Oh, I have shared it.
Yeah, ma'am, please share.
It is not visible.
Is it now visible?
Yes, ma'am. Yes, yes.
Yes, now it's showing.
Okay.
Ma'am, can you please take it from the start?
This is Bhavan Vidya Mandir, Civil Lines, one of the reputed school in Nagpur, where we have performed this water audit, and the students of the school have done good job, a very good job over here. And this success story we have done. Yes, this is the first success story. That's why we are showing it this story only to everyone, but so many are there now, so many in school, so many schools and colleges we have done these activities, and now the students of these schools and colleges are taking part into these type of activities. So we are not going for these activities now randomly like before. So here you can see why is water audit needed. Students have given very good. And you can see over here, by sitting beside the bathroom and just taking that idea that how much water a person is consuming for bathing, they have monitored, and they have given this data for drinking 7 liters. They have actually measured this by their self and did all these calculations. They have not taken this data from anywhere, or internet or any book or anywhere, but they have personally did this all things, and they have given this value as 115 liters per day per person. Water consumption is there in our home. So zero death scenario they have mentioned over. With that, what water audit workshop we have conducted with our team, that is, I have pasted over here. Then based on the workshop, a screening test was conducted. Actually, so everyone was interested to take part in this type of activity, but we were having some limitations. We could not handle this many students. So 100 students gave the test, 40 were got selected, and then we have made 4 teams of them, which one of which is for garden, one was for resources of water, third was for wastewater treatment, and then fourth was rainwater harvesting team. The next session was conducted for water testing and basic information about the water and how water testing is performed, how to collect the data, how to take a catchment area, how to measure the rooftop area. All these instructions were being provided by us, with, yes, in presence of teacher and the staff of the school. Then you can see over here some teams, they have put very good photographs over here. Rainwater harvesting team this is, and what work they have done. They have seen the outlets of the rooftop area coming to which point. These are the provisions for rainwater harvesting system, but water is released into the drain. They have observed this, and then they have solved this issue with so many observations. Water from the auditorium and from washroom meets at a common point here in the drain. You can see here the whole sewage of school being connected to a common point here. All these things they have monitored. With this catchment area they have found in rooftop, they have actually taken the measurement of that catchment area, but water was not getting harvested and directly getting released into the drain. So rooftop area was 6,254 meters square, 42 meters. This from Google Map, they have monitored this area, and yes, manually also they have done some calculations with the area, and they have got this. Then according to these calculations, we can save. This is the Excel sheet, what I have shown to you just now. And with this Excel sheet only, what they have got is 28 lakhs 14,300 liters of water they can harvest yearly from their school from 2 rooftops. Then average annual rainfall in Nagpur they have calculated. Yes, through the meteorological data only, they have found this. The annual rainfall of Nagpur is 1067 mm. So with this, they have done the calculations. They have taken the monitoring for last one year, rainfall in 2019-20 for months, various months. Water consumption for August 2019. They have given it building wise, how much water was got consumed. Total units used in school is 1,353 liters. Units, which is equal to 1,353 into 1,000 liters. Okay. So this much of water is used. That means we can say that 13 lakh 53,000 liters of water is being used by school in August 2019. So if suppose this is the area by rainwater harvesting, the double of the water, that is liters in because 28 lakhs of liters of water we can harvest yearly. So if in 1 year this much of consumption is there, with the rainwater harvesting system only, you don't need to ask for any corporation help to get the extra water, right? So this is proposed site under which we can construct a tank for water harvesting means. So previously they have given this presentation in front of management and in front of committees of their school and different organizations, and they have given this area proposed site where the rainwater harvesting system could be, and now they have mounted it. Then students were interviewing some of the peoples who are using water and who are dealing the water usage, who are dealing with the water usage of their school, and with the garden team, then with the wastewater team, and so many other teams also, 4 teams. This is again now resources of water team. So sources and uses of water in our school. So if unless and until we are not getting the data from where the water is getting consumed and how much water is going to drainage, how could you say that how much capacity of ETP plant or STP plant you need? So for that, the sources and uses of water in school or college or any organization area, we need to know. So NMC water is used as drinking water, pour water is used for washrooms, well water is used in the garden. They have monitored this. They have asked the peoples of respective uh, departments. Then storage of water in our school, number of NMC pumps, 4 they have found, and these pumps are activated 3 times a day. They have monitored that data also from 7:30 to 9, and NMC water is supplied for drinking from tanks under portico, and number of tanks under portico for storage is 3. So you can see NMC water is supplying drinking water in tanks. And 2 tanks of 10,000 liter, 1 tank for fire extinguisher and 1 tank for drinking. They are regularly ordering from NMC for these buildings, auditoriums and pre-primary. Then water storage above annex building, then cement tank with capacity, how much capacity is there, they have mentioned over here. Syntax tank, all the data whatever is needed for this study, they have very well managed and kept on to these slides. You can see over here how many syntax tanks are there, what is their capacity, and to where these water tanks are giving supply for the drinking, for the washrooms, wherever. They have mentioned everything, and they have put it in the chart, which already I have shown to you on that Word document. And then water in school is used for flushing, washing hands, drinking. And then they have calculated the average usage of water in their school is about 20 liter per person, apart from the bottles of the students which they are carrying from their houses. There are a total of 3,631 people, that is including students and staff in the school. Hence total water used in the school is this much, 7 lakh 26 sorry 72,620 liters per day. Per day it is. Then STP calculator. So if suppose this much of water is getting used, means this all water is getting drained off. But if suppose we can reuse this water by putting one STP, wastewater treatment plant or sewage treatment plant over there, so how much KLD capacity, or we can say how much capacity is needed for STP. So they have calculated it by their own. See, you can see over here number of students 3,200, number of teachers they have mentioned over here, number of staffs, total head counts. They know per person how much water is required. Then As per MPCB, quantity of water consumption for school in liters is 20 liters. So total water consumption in liters is 72,620. They have put this value in this calculator. This calculator is also I am having. I have I can provide it if suppose you want it. Otherwise, this can be made in Excel sheet very easily. So then diversity factor 85%. It will reduce this much of water. Then safety margin 10%, means this much of water is getting wasted, will not get into the use after treatment procedures also. And total load for sewage treatment is 67,899 liter per day. Then the capacity of STP required will come automatically, which is 67.8997 exactly in KLD, kiloliter. So for 50 KLD, STP will be sufficient for their school, and they have given this data. And yes, after that, they have monitored the parameters of the quality of water by simple test kits. Means if suppose they wanted to determine the TDS, no need to go for TDS meter. Okay, no need to go for a heavy instrumentation. We are having pH meter, TDS meter, handy meter is there. So with this, they have monitored their school water parameters. Even effluent parameters also they have monitored for basic elements like pH, TDS, hardness, EC, all these things they have monitored, and they have given the specific things regarding this, what they have got from our lectures. And the quality parameters, pH, hardness, electrical conductivity, TDS, the value they were getting for the water in their school, and average healthy value, means limits, desirable limits they have mentioned over here. So the TDS level in water is this. They have given very good data. Now this is the team of wastewater management. There are two types of wastewater again they have mentioned over here. This team was actually setting up the instrument, and this team will monitor where to set up the instrument, and how to process with it with the pipelines and everything, because from so many areas the drain is the pipelines are coming and connected with the drain. So they have monitored everything. They have seen that how much washrooms are there, how many washrooms are there, many buildings for boys washrooms, 20 for girls washroom, annex buildings, auditorium, and this much data they have collected. Then these pipes from where the drain was coming out to the drainage system. Then total water used for washroom was 35,000 liters into 3, that is 1,05,000 liters. So number of refill of tanks for water is this much. Now various processes of wastewater treatment, aerobic process, physical water treatment, biological water treatment, chemical water treatment, sludge water treatment they have mentioned. Then what garden team has done? Garden team has monitored that number of gardens, how many are there. Uske baad the number of plants, then irrigation source, how much water is needed per day. They have calculated that is 1,500 liter per day of water they are consuming in their garden. From all this data, NMC water, what they have used is mentioned here, 40,000 liter per day. Borewell water they are using is 1,05,000 liter per day, and well water they are using is 1,48,000 liters per day. So with this, then they have implemented all the things, and with this success story and all the things. Yes, I wanted to thank you. I wanted to go to my presentation now. Yeah.
Ma'am, can you please explain how to calculate and go for auditing?
Yes, ma'am. Pardon. What?
Ma'am, how to go for auditing and how to calculate?
I'm not getting your voice clear.
Ma'am, can you please?
No. So much disturbance is there. Hello. Hello.
Yeah, ma'am, can you?
No, ma'am. Hello. Hello. Hello.
Can you hear me, ma'am?
Yes. Yes, ma'am. Yes. I can.
Hello.
Yes, ma'am.
Ma'am, can you hear me?
Yes, ma'am. Say.
Yeah, ma'am, please, in short, can you explain how to calculate for the water audit?
Ma'am, I have shown you the sheets. With these sheets, if suppose you are having the data of usage of water for per day also, or per year also, if suppose you are having a per person per day data, if suppose you are having, and with that data only you can put that data. I have shown you this sheets. Just a minute,
Yeah,
I'll again open it.
yeah,
And
ma'am,
with
please.
this sheet, you can calculate all the things. This is for rainwater harvesting with the rooftop area. And this sheet, you can see, ma'am. This is the Excel sheet we have prepared. I can forward it to you. With this only, you can calculate how much water you can save, and with so many calculations that how much water per day a person is using, you can find with the simple calculation, multiplication, and number of peoples, how many number of peoples, how number of peoples working in the office for the shifts, and for so on. You can multiply it with the number, and you can calculate the amount, that how much water is getting consumed per day. With the day you can find the data with the annual also, because see madam, somehow the data is not getting changed for seasons. If suppose if suppose we are taking example of school will be open for some period of time only, so that much of period of time with that months, you can multiply it with the value, and you can get. These students have done this. I can share with you that student have explained this. Mhm. Very well. And they have yes, they have written out there that with the simple multiplication number of peoples. I have shown one that sheet also, ma'am. That one sheet. That how many staffs, how many staffs are there, how many students are there. With that data, they have multiplied the usage of water per liter per day, and they have got the consumption. Rainwater harvesting with the rooftop area and rainwater fall. See over here. I can share this PPT also, no issues. Yes, this 20 liter per person with the flushing, washing hands, drinking, and then they have calculated it for total number of peoples. You can see over here, ma'am. Ma'am, is it is the
Yes, ma'am, I
document
can see.
shared?
Yes, ma'am, I can see the PPT.
There are a total number of 3,631 peoples, student plus staff in the school, and then per liter, 20 liters per person was the count for their school. For one person, actually, they need 20 liters. So they have multiplied it and they have calculated. Right, ma'am? So I
Right,
think
and so we need to calculate the water used by per person. Right?
per person, yes. For that, this students or the peoples has to take help of all the peoples, means all the you can do it with water bills, ma'am. With the water bills per day, one person how much is using, you can make that data. Or otherwise, I told you that the students were be- beside the door of the bathrooms and ask people how much water you poured, one jug, how much it is, and then they calculated in that way. But it is very simple. If suppose this data you are getting for school, 20 liter per person, near about the same data we are getting for office used, uh, uh, offices also, offices, rather not for offices but for colleges and schools, we can get this type of data, 20 liter per person actually. And with offices also I can say, and you just multiply the people, number of peoples with it, you will get the total usage of water. In your home also you can try this experiment. You can find this is near about 20 liter per person for drinking, flushing, washing hands. And now for corona, ma'am, it is more random to wash hands. So we need more water.
Ma'am, it's a request that can you please show the graph? That time it was not visible.
Graph.
There was a graph you said.
No, that was for just rainwater, rainfall in Nagpur city.
Okay.
This was for water consumption for August of their school. And this data, they
No, ma'am,
might,
there's one another file which you didn't open.
this one, rainfall.
No, ma'am, it was not in PowerPoint. It was other than the PowerPoint. You said you wanted to show some graph.
Not graph, but
There might be some chart or something in there. The
huh,
file didn't
that,
open.
that I have shown. Okay, that was the
Yeah,
report actually.
yeah, ma'am. Please, can you do that again?
Okay, okay. I'll send all the document to your mail.
Yeah, sure.
Yes, with this flow chart, you will get the idea what to do, how to do, and everything. And with the rainwater harvesting calculator and STP calculator, you'll get all the desirable permissible limits for STP implementation, STP and rainwater harvesting. This is the document, ma'am. Here, see, unit consumed, water consumed.
No, ma'am, I cannot see it, ma'am.
Oh. Now?
Yeah, now it's fine.
So this is water audit flow chart. How to conduct this audit, water consumption pattern. So in first quarter, second quarter, third quarter, fourth quarter, actually 4 semesters are there in school. So we have mentioned, we have put it like this, and according to that, and that leaves and so many things are there in school. So we have given it in 4 quarter. You can manage it according to your organization, and you can take the data on this sheet. With this amount of water consumed, water consumption per year, water consumption per month, 2019, 2020, this data you'll get if suppose you are regularizing the things in such a way that it is not a burden and a day-to-day activity. Water consumption per month, water consumption per day, then utilization of water in college campus, drinking, washroom, laboratory, canteen, garden, floor cleaning, other utility. First time it will be difficult, ma'am. Then it will be very easy to monitor all these things for any type of organization. And nowadays it is a very important thing that we should monitor our water usage. Utilization of water has to calculate from data collected, number of tabs in washroom, flow rate per minute, number of storage tanks, number of water coolers, capacity of storage tanks, frequency of tank fill, etc. Then finding leakages in taps. If suppose yes, then note down and rectify it. Then specify if yes and do this type of things, rectify it. After conservation technique implemented, rainwater means these are the things. If suppose we are having, you have to mention it yes or no. If suppose yes, then how efficiently it is working, that also you need to monitor. Rainwater harvesting system is having catchment of rainwater in volume per liter. You have to write down over here how much is that. Then rainwater harvesting in volume in liters, you have to write it here. Then reusage of rainwater in volume means this will be again your routine activity. Yearly you have to monitor this, you have to do this, so that the water usage, water consumption, and regular water will be conserved in this way and reused also. Sewage treatment plant also, capacity of STP in volume again. Then recovery of water in volume, reusage of treated water, how much of water is getting reused. Now this water you can use for flushing and gardening and so many these type of works. Then condition of sewage treatment system. Then annual net water saving by plugging leakage through STP, through RWH, that is treatment. Total saving of water, total saving, how much in rupees, you can put it here. Then recommendations and submitted by. These all things you have to keep it as a report. And if you wanted to submit it to the management or authority, you can submit it, you can take actions, and you can perform very well, ma'am, with this type of zero water scenario.
Are there any questions from the participant side?
Hello.
Yes.
Yeah, ma'am. Good afternoon. I'm Nasreen from Invertis University, Bareilly. Thank you so very much for giving such a lovely information on the topic. I was looking for the same. I'm pursuing my PhD on water treatment, ma'am, and this presentation was very helpful for me, ma'am. Really very helpful. And I would love to say thank you to Devanshi, ma'am, for adding me in the group. I have requested, ma'am, because I was a little late. So I've requested, ma'am, and she really accepted. Devanshi ma'am, thank you so very much. Ashish ma'am, I just want to know more about this, heavy metal treatment. And though I'm doing with the bioremedial process, so I really love to have your guidance on that. Equally, I need your PPT so that I can read it again, because many of the parameters I just love, and the permissible limit I really wish to have again. So may I have the PPT and the more guidance from you, ma'am, in future?
In future also, yes, you can have my email ID. I have shared it with Devanshi ma'am. She will share it with you. And yes, very good work you are doing on heavy metal remediation, right? Yes, recently I'm having one DST project in which I'm looking for, means I have designed one material which is a hierarchical material for arsenic adsorption. So for that arsenic, I am using ICP-MS, inductively coupled plasma spectroscopy with spectroscopy. So for that, all the things I have done, and yes, I'm having that experience. I have done the fluoride, arsenic. Have you selected metal for that?
Yes. Lead arsenic. Yes, I have selected lead and arsenic. Yeah.
Very good. Very. After and what bioremediation process you are going to carry it out?
Yes, ma'am. Actually, we have detected and we have experimented and we have found many metals, but I have chosen three metals especially, and we are looking for some plant remediation. I have I have done lot many work on that, looking for more plants, looking for more plants who can absorb the heavy metal. And my work is on Ramganga River, so I'm going there. I'm searching for that. So I need your guidance. Yes.
Yes, definitely. I'll be in touch with you in future, but now it will be very time consuming if suppose we will talk about bioremediation process. And so I think
that is why I need your personal details, so that personally I can request you for further help,
yes,
ma'am.
my number is with Devanshi ma'am. You can take it. My email ID is also with her. No issues.
And
Okay.
I need your PPT also. This PPT was
Yeah,
very, I could not even blink. I was just looking your PPT continuously. So that is really very helpful.
yeah. I will send this to Devanshi
Thank you
ma'am. You
so very much. Thank you
thank you.
so very much. Stay safe, ma'am. Have a very good day. Thank you.
Yes, same to you. Same to you.
Thank you, Nasreen. Is anybody else interested in clarifying the doubts?
Hello.
Hello. Yes, ma'am.
Hello, ma'am. I'm Mamta Tendulkar from Mumbai. I'm
Yeah.
teaching in Somaya College Environmental Studies.
Oh.
So I like your project, actually, what you have conducted with the student, and would like to get in. Would like to get connected with you.
Oh, very nice, ma'am.
Get more
Actually,
guidance.
we wanted to explore this water audit activity outside India, means outside Nagpur also, but we are not having enough time because all of us are from different background, from mechanical engineering, from so many different backgrounds we are coming from. So we are having individual work with us, and apart from this, we are doing this activity. So no issues. You can have my number. You can call me anytime. We will be there if suppose needed, and we will guide first time for this water audit activity, and then afterwards you will be doing it very
Yeah,
nicely.
thank you so much, ma'am. Because in Mumbai, we always face the water scarcity problem,
Yeah, I
and
know.
it's really very important to do the water auditing. And rather than more than that, students should understand it, like
Yeah,
how to do it, and then they will get sensitized towards the water conservation as well. And I
ah,
really like this part of your PPT a lot. Apart from
thank
that, yes, the whole PPT was good, but this is what was being a assistant professor for me. This is something more catchy and important.
you. Very
Thank you
nice.
so much, ma'am.
Thank you so much.
The more you do it by yourself, the easier it becomes.
Ah,
Yes, yes.
yes.
So anybody else who's interested? So I hopefully think there's nobody and no other doubt. And so thank you so very much, ma'am, for a wonderful explanation about
Thank you.
the quality of water and how should we test it, the important parameters, the standards which are required. Along with that, how we can go for a water audit so that we can have a rainwater harvesting system also, and how can we conserve and preserve water. Thank you
Yes.
so much, ma'am, for the
Thank you
detailed and
so
lovely
much, ma'am.
explanation.
You have given me this opportunity, and yes, I would like to connect with your organization again in future also, and I'll be there. Just take my number, take my email ID. I'll connect with all of you for any future in future work in this regard. Thank you so much. Thank you, ma'am.
It was a pleasure having you, ma'am. Thank you so much. So the participants are requested to join tomorrow again at 11:45 a.m. and we'll be continuing with the session tomorrow. So that's for today. Thank you so much. Thank you, ma'am.